Today we are beginning Unit 3, Modeling Functions. The graduation standards covered will be Graduation Standard 1, Reason and Model Quantitatively using units and numbers to solve problems. That's a supporting standard. Standard 2, Interpret, Represent, Create, and Solve Algebraic Expressions. And Standard 3, Interpret, Analyze, Construct, and Solve Linear, Quadratic, and Trigonometric Functions. Standard 3 is the one we're focusing on the most here. Your performance indicators that we will be covering are as follows. Represent and solve equations and inequalities graphically. Understand the concept of a function and use function notation. Interpret functions that arise in applications in terms of context. Analyze functions using different representations. Build a function that models a relationship between two quantities. Construct and compare linear, quadratic, and exponential models and solve problems. Your learning target for the day, I can create a relation as a table, mapping, or graph. I can also find domain and range of a relation. First, we need to discuss what is a relation. Well, a relation is a set of ordered pairs. It can be represented by a list of ordered pairs in a table, a mapping, or a graph. A little background before we get into that. Most of us already know about coordinate planes. However, the line going horizontally is your x-axis. The center point is the origin, that is 0, 0. And the vertical line is your y-axis. All of your points are based around those. The first quadrant is the top right-hand side, and it goes counterclockwise. So quadrant 1, 2, 3, and quadrant 4. If there are no numbers written on your axes, you assume each box is 1 unit. Every point is always an x and a y. The x coordinate comes first, the y coordinate comes second. So let's look at a few different points here from the graph. I'll start with one on the x-axis. This point, our x coordinate is over 1, 2, 3, 4, 5, 6, and we haven't gone off the x-axis, so our point is 6, 0. We went positive direction 6 and up 0. On the y-axis, point at the top, we've gone over 0 in the x direction, but we've gone up 1, 2, 3, 4, 5, 6, 7, 8. So our point is 0, 8. Point in quadrant 1 is 1, 2, 3, 4, 5 over in the x direction, and up 1, 2, 3, 4, 5, 6, 7 in the y direction. All points in quadrant 1 are positive x's and positive y's. In quadrant 2, a point over here will have a negative x and a positive y. We have gone back 2 spaces with our x, so negative 2, and up 1, 2, 3, positive 3 for our y. In quadrant 3, we have a point that will be negative x and negative y. We have gone back 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. So our point is negative 6, negative 6. Lastly, quadrant 4, these points have a positive x and a negative y. This point we have gone to the right, 1, 2, 3, 4, and down 1, 2, 3. So over 4, positive 4, negative 3 for the down 3. if you're given a point, use those same rules to plot that point. For example, negative 3, 0 would be over to the left 1, 2, 3, but up 0. And that is my point. Guess that moves all at once. That is my point, negative 3, 0. Okay. If I want to graph 0, negative 5, we start at 0 and just go down 1, 2, 3, 4, 5, and that is 0, negative 5. The point 2, 3, since both are positive, ends up in quadrant 1. To the right is the positive direction 2, and then up 3 gives me a point 2, 3. Oops, that was actually a So you get the idea when you're graphing points, x direction first, y direction second. We also said we can represent relations as a mapping, a table, and a graph. A mapping is one way to separate your x's and your y's. When we talk about x's and y's, there are more specific names for those. Your domain is all of your x values. It is the set of the first numbers in the ordered pair. So if you're doing an application problem, maybe you aren't using x and y, but it's the first set. If you have a point 1, 2, well, 1 would be part of my domain. It's the first number. Your range would be the set of all your y values, so the second number. In this point, 2 would be part of our range. Right? A mapping shows that each element in your domain has an element in the range. And when we start talking about functions, we'll have to be more specific, but a mapping could look like anything as long as you have a domain and a range. We use arrows to determine which domain number goes to which range number. When we list domain and range from a set of ordered pairs, we like to use set notation. So I will start with my set brace, and if I look at my x values in my mapping, we have 1, negative 2, and 0. We want to list these least to greatest and have no repeating values. Well, the smallest number is negative 2, the next smallest is 0, and finally 1. When you do your range, it's all of your y values. Again, we want set notation. So I have my set brace. My lowest number is negative 3, next is 2, and lastly 4. So there I've listed my domain and my range, separating the x's and the y's. Sorry about that. Here we have shown that same relation. We have now written out our ordered pairs, and usually we want to write it as a set of ordered pairs. So again, set brace, we have the point 1, 2, comma, negative 2, 4, comma, 0, negative 3. Close your set brace. As a table, you're matching up the x's and the y's. This is the point 1, 2. This is the point negative 2, 4, and 0, negative 3. As a mapping, we're showing that each x value goes to a y value. So that would be the point 1, 2, because our x is 1 and it goes with 2 for a y. Your mapping does not have to go least to greatest, although it can. Finally, as a graph, this is what we talked about earlier. Our first point here is going to be negative 2, positive 4. The second point is over 1, up 2. And the third point is 0, negative 3. So all those points are represented as a set of ordered pairs, a table, a mapping, and a graph. Let's do one practice here. Express this relation as a table, a mapping, and a graph. First, as a table, I make a chart, a T-chart. The left side are my x values, the right side are my y values. So I'm going to go through and list all of my x values. We have 3, we have -1, 0, -3, and -2. When you do a table, you should see repeating values if you have those. We want to match up the y values that go with those. This first point is 3, 2, so next to the 3, I'll have the 2. -1, 4, 0, -3, -3, 4, and -2, -2. So that would be my table. With a mapping, we want 2 bubbles, one for our x's, one for our y's. If you have repeating values, you don't want to repeat, and again, they don't have to go in order from least to greatest. So for my x's, I need the numbers 3, -1, 0, -3, and -2. For the y's, I need 2, 4, -3. I don't have to write 4 again because it's already shown, and -2. In order to complete the mapping, we need arrows. So we need to create the points. 3 goes with 2, and -1 goes with 4, 0 with -3, -3 also goes with 4, and -2 to 2. So we have a table, we have a mapping, and now we need to make a graph. So I'm just going to sketch a graph. You will have graph paper most likely to do this. My first point is over +3 and up 2. My second point is back 1 and up 4. My third point is at 0, -3. My fourth point is at -3, +4. And my last point is at -2, -2, -2. So there we have our graph, which is the third piece and final piece. Now it's your turn. Try problems from worksheet 1-6.